Hello student friends, hope you are in good health. So today we are going to learn Vander Waals equation. Vander Waals equation is associated with two constants A and B. So we will learn more about them, units of A and B, and how we can compare A value or Vander Waals constant A with respect to different gases, and how can you compare B, another Vander Waals constant for different gases. Go ahead and understand it well.
So we want to learn Vander Waals equation, want to understand Vander Waals equation. We are aware Vander Waals equation is given by a formula P plus an square by v square, and v minus nb is equal to nRT. This is what is Vander Waals equation, where A and B are Vander Waals constant which depend on nature of gases. Here we want to understand more about these constants. Significance of Vander Waals constants. Vander Waals constant A, which is a factor responsible in pressure correction. You know, pressure correction is due to what? A pressure correction is due to attractive forces, or to be correct, more precise, intermolecular forces. For major gases it is attractive forces. Therefore, A factor is a magnitude of attractive forces present between the molecules. Greater is the value of A, larger are attractive forces. A stands for attractive forces. So, what will be the value of A for hydrogen, helium and neon, which in standard temperature pressure conditions or normal conditions have repulsive forces? These are the three gases which have repulsive forces. For these three gases, the value of A will be taken as 0 because A is used for attractive forces. So Vander Waals constant A tells you or measures magnitude of attractive forces. So if you are somebody, right, is want to compare A of ammonia and A of methane, then A of ammonia is found to be greater than A of methane. Reason is ammonia has strong hydrogen bonding present, while methane has weak London forces as intermolecular forces. So we can compare A for various gases based on intermolecular forces. A good understanding of intermolecular forces will help you to understand A. We go to next Vander Waals constant B. Now if you are aware, B is for volume correction. If you remember, volume correction was due to space occupied by the molecules, where NB is a space occupied by n moles of gases in compact arrangement. So B is for volume correction. If it is for volume correction, then it will be a measure of magnitude of size of gas molecules. If you remember, B was given as 4 times Vm, where Vm is the actual volume of gas molecules. So B is 4 times of this. It is also called as excluded volume, or it is also called as co-volume. Remember, it tells you about size. So if you want to compare B of ethane, B of methane, naturally B of ethane will be greater than B of methane, since ethane is a bigger molecule in the size. Now in entrance examination, they ask you to compare A for various substances. Imagine they ask you to compare A for ammonia and A of water. Your good understanding of their intermolecular forces will help you to understand A also. A of water is greater than A of ammonia. But why? Because water has higher boiling point than that of ammonia. How you know that water has higher boiling point? because in real or at room temperature, we are aware water is liquid and ammonia is gas, and substance which is liquid naturally has higher boiling point than a substance which is gas. Therefore, intermolecular forces of water are greater. Therefore, A of water will be greater. Which molecules have larger value of B? Then, right, chlorine and fluorine, if they are compared, we are knowing B of chlorine will be greater than B of fluorine, because we know chlorine atoms are bigger in size than fluorine atoms. So naturally, chlorine molecule made up of 2 chlorine atoms and fluorine molecule made up of 2 fluorine atoms, size of chlorine will be greater than size of fluorine. Now more about A and B in terms of their units. Now units of A should be same as units of AN square by V square. Why? Because if you remember, this is what is a formula given. So P and AN square by V square dimensionally should be same. So we are writing it equally only from dimension perspective. If you are saying like that, then A will be P multiplied by V square divided by N square. What is a unit of P? Atmosphere. What is a unit of volume? Liter. So liter square. And what is a unit for number of moles? Moles. Therefore, units of A will be atmosphere, liter square, and mole inverse 2. If you remember in that same formula, P plus AN square by V square, another factor was V minus NB is equal to nRT. So dimensionally, V and NB should have same units dimensionally. So dimensionally they are same. So B will have units of volume upon number of moles. Volume is liter and moles is mole. Therefore, units of B will be liter mole inverse. So that was about units of A and units of B, and we have said units of A will be same, or units of pressure will be same as units of AN square by V square, and units of V and NB is same. So this equality is from units perspective, and from that you can get units of A and you can get units of B.